river water is flowing with speed VW. You are not concerned about this thing that whether you will be reaching at this point or that point. So if he wants to cross a river along the shortest path. Hello everyone, welcome to Alan Overseas. So continuing this special series of 45 important questions in 45 days, in which you guys will be provided with 15 important topics from each subject, that is physics, chemistry and mathematics. And obviously, as you guys must be knowing, that I'll be dealing with the physics subject. Okay, so this series is very much important for all the aspirants of JEE Main 2024. So the whole link, the link of all the videos of this 45 series is present in the description box, so don't forget to watch that. So moving on to the topic of today's lecture, we'll be dealing with the most famous riverboat problems. So I'll be explaining you these riverboat problems in a very crisp manner as they are very important to us. So beginning with them, so when we talk about the riverboat problems, it basically deals with the different cases in which we can cross the river with the help of a boat and based on different situations. As means, like to cross a river, basically we have two categories. Okay, first of all, crossing the river in minimum distance by using minimum distance of approach, which is also called as crossing the river along the shortest possible path, and which is also known as crossing the river and reaching a point just opposite to the starting path. So they all are the same thing. Okay, these are just the different names given to them. Second category is this, that crossing the river in the shortest possible time. These are the two main classifications in which the riverboat problems are categorized. So let's discuss it from the very scratch. For an example, let's say this is the river of width d. So first of all, let's understand what are the problems that we are not able to cross the river in the direct manner, like reaching the point in the directly opposite point. So let's say this river water is flowing with speed VW, velocity of water. Let's say you are starting from this point and you want to reach the exactly opposite point. Okay, so in general, what will come to your mind, like let's start with this, in this direction, let's start. Let's say the velocity of the boat or velocity of the man who is swimming is, let's say, Vm. Okay, you started swimming in this direction hoping that you will reach the exactly opposite point. But there's a problem. What's that problem? And that's the problem because of which we are discussing the riverboat problems. So the thing that happens is this, that river water is also flowing. So when river water is also flowing, so if you will see the velocity of the man with respect to ground, if you will see the velocity of man with respect to ground, this is not with respect to ground. This is if water would be still. If water would not be flowing, then this would be the velocity of man. But since water is flowing, so if the man is trying to walk or swim in this direction and river water is making him flow in this direction with velocity of water, so obviously the resultant velocity of the man with respect to ground will be lying somewhere between Vm and Vw. Okay, and it will be better if I will say that this is velocity of man with respect to water. That means if water would not be moving, right? So you will, instead of going directly in the opposite sense, you will end up going somewhere over here and you will reach at this point, which will be, let's say, some distance x apart from the point where you were supposed to reach. Okay, and basically this x is called as drift. This is called as drift. Now, I hope you guys understood the problem, that why I'm not able to reach at exactly the opposite point, because the river water is also making me flow with the water itself so that I'm reaching at some other point. Now, the topic says that how we can reach using the shortest path. So obviously the shortest path is this path, directly reaching this point. How can I reach the directly opposite point using the shortest path? See, this velocity of water is making me move in this direction. Okay, so if I will direct my velocity, let's say I'm the swimmer. If I will direct my velocity, let's say this is the river. This is the velocity of the river flow. Okay. And if I want to go on this line directly opposite, so what I can do is, I can do this thing. I'll try to swim in this direction. Velocity of man with respect to water. I will try to swim in this direction, and this direction will be in such a manner, let's say this angle is theta. So if I will take the components of this velocity, so it will be velocity mw, velocity of man with respect to water, cos theta, and this component will be velocity of man with respect to water, sin theta. This velocity of water is also making this man flow in this direction. So let's write this velocity of water as well. So I'll try to swim in such a direction that one of the component of my velocity, that is Vmw sin theta, will cancel out this velocity of water flow. I'll try to flow in such direction so that this velocity will cancel out this velocity. That means the horizontal component of velocity will not be there with the swimmer. Like for in the plane of the board, I'll be calling it as horizontal and vertical, right? Like in the real case, both of them are horizontal, like either going in the, horizontal or either crossing the river. But in the board sense, we can say that it is horizontal and vertical. So yeah, I can say that the swimmer, that is me, I won't be having any horizontal component. So I'll end up reaching the exactly opposite point. I'll end up reaching exactly opposite point. And in how much time I'll be reaching? This is also one of the part, that how much time you will be taking to cross the river using the shortest possible path. So I can say that time is nothing, basically distance upon speed. So distance that the man swimmer is covering is d, and the speed with which the man is covering the distance is v cos theta. Okay, not v sin theta or vw, because they are getting cancelled out with each other. They are getting cancelled out with each other. That's why the velocity of man that will be visible to someone who is standing on the bank of the river and observing the person will be Vmw cos theta. Okay, so with this velocity the person is moving, so time taken will be d upon Vmw cos theta. This will be the time taken. This will be the time taken to cross the river in this case. Okay, in general it is also called as T will be equal to width of the river divided by V perpendicular. V perpendicular means that velocity which is perpendicular to the river flow, that velocity which is helping you to cross the river. This is the direction of the river flow, water flow, and the velocity which is perpendicular to it will be taken as in the account for crossing the river. So this is the case for crossing the river in the shortest path, okay, in which we direct our velocity in such a way that one of the component of our velocity will cancelling out the velocity of water flow, and the other component will help us to cross the river and reaching the point exactly opposite. I hope that is clear to everyone. We will see the questions as well. But before that, let's see the case for crossing the river in shortest time as well. Okay, so when we are not worried about the point that where I want to reach, but we are concerned only about the case that I want to cross the river in the shortest path possible. Okay, let's say again, this is the river, okay, of width d. You are not worried, like let's say you are starting from here, you are not concerned about this thing that whether you will be reaching at this point or that point. You are just concerned regarding the thing that you want to cross the river in the shortest time possible. Let's say a crocodile is behind you. Okay, so you won't be considering that where should I reach on the other bank. You will be just concerned about this thing that yeah, I want to cross the river in the shortest possible, shortest possible time so that I can be alive, right? So yeah, let's say the swimmer is starting from this point. And as I said that the swimmer is not worried about where he will be reaching. So if you will think it in this manner, that the velocity which was helpful in crossing the river was that velocity which is perpendicular to the river flow, right? The velocity which is helping us to cross the river is that velocity which is perpendicular to the river flow. And I can say this as well, that more will be the velocity which is perpendicular to the river flow, lesser will be the time taken, because time taken is what? D upon V perpendicular. So more will be the V perpendicular, lesser will be the time taken. I can say that, right? So what I can do if I want to cross the river in minimum time? I'll use whole of my strength, I'll use whole of my velocity, my power, my strength to just cross the river. I'll use whole of my velocity of man with respect to still water, okay, in the direction just to cross the river. I'm not saying that I'll be going along this path. No, I didn't say that. I'm just giving my velocity in this direction. Definitely I'll be having velocity of river as well, which will be taking me, like the velocity of river will also be helping this man. So ultimately the man will end up somewhere over here. That's for sure. He won't be reaching the exactly opposite point because yeah, river water is also flowing. But the man will be able to cross the river in the shortest possible time. Okay, so if I want to cross the river in the shortest possible time, so I'll be giving whole of my velocity in the direction perpendicular to the river flow, and the minimum time that will be taken will be nothing but the distance of the, or I can say the width of the river divided by the velocity of man with respect to still water, velocity of man with respect to river, or velocity of swimmer with respect to river, velocity of boat with respect to river. There are a lot of names for them. Okay, we just need the feel, right? So in order to cross the river in the minimum time, I'll just give whole of my strength to swim just in the direction which will be helping me to cross the river. That is perpendicular to the river flow. Okay, so let's now see few of the questions, and then I'll be giving you the PYQs as well. So let's see this question. What this question is saying basically, that a river of width 1 kilometer is flowing with speed 1 kilometer per hour. Okay, a man can swim with speed 2 kilometer per hour in still water. So if he wants to cross a river along the shortest path, then find out these three things, right? So let's say this is the width of the river, and the width of the river is basically 1 kilometer, and the man can swim with a speed of 2 kilometer per hour in still water. In still water means, that means the velocity of man with respect to water is given to me as 2 kilometer per hour. Okay, that means if water would not be moving, then the person could be swimming with 2 kilometer per hour. Okay, so let's say the person starts from here, and if he wants to go with the shortest path, so speed of the river water is how much? 1 kilometer per hour. Okay, now as I told you that the person wants to cross the river using the shortest path. So he wants to go along the dashed line, right? So let's say the person is moving in somewhat this direction. Let's say this angle is theta. Okay, so person will be giving his 2 kilometer per hour in such a direction that one of the component, that means this component, that will be 2 sine theta, will be cancelling out the velocity of water flow, so that the person can only have the velocity in the direction perpendicular to the river flow. That will be 2 cos theta. So since we know that the particle wants to, the man wants to cross the river in the shortest path, so this 2 sine theta should be cancelling out 1 kilometer per hour, and it is possible only when they both will be equal. So I got the value of sine theta as 1 by 2. That simply means that theta is nothing but 30 degree, right? So speed of man with respect to ground we have to give. So speed of man with respect to ground, that means if a person is observing this man swimming standing on the ground, so he will be seeing only this velocity 2 cos theta, because he will be seeing the man crossing the river using the shortest path, that means directly this vertical line. Okay, so if I'll be talking about velocity of man with respect to ground, so it will be 2 cos theta, and it will be 2, and cos 30 degree will be root 3 by 2, so it will be nothing but root 3 kilometer per hour. That's what the answer to the first part. Talking about the next one, time of crossing. So talking about the time of crossing, as we discussed, time of crossing will be nothing but width of the river divided by the velocity which is perpendicular to the river flow. So width of the river given in the question is 1 kilometer divided by velocity which is perpendicular was 2 cos theta, which is root 3 kilometer per hour. So I got the time, that time taken will be nothing but 1 upon root 3 hours. That will be the time taken. That's what the answer to the second part. Talking about the third one, direction of swimming. So there are a lot of ways of answering this part, direction of swimming. We'll be discussing all of them. Like we found out that this theta is 30 degree. So I can say that this total angle will be 90 plus theta, which is 90 plus 30, that means 120 degree. So either I can say that direction of swimming is 120 degree from direction of river flow. Either I can say this, or I can say 30 degree from the direction perpendicular to the river flow, or I can say 120 degree from downstream, or I can say if this is 30, so this will be 60 degree, so I can say 60 degree from upstream. All these four statements mean the same thing. Okay, it just depends what is provided to you in the option. Okay, so I can call it as 120 degree from downstream, or 120 degree from direction of river flow, 30 degree from direction perpendicular to river flow, 60 degree from upstream. This will be upstream because water is flowing in that direction. So in these manner, I can answer this third part. I hope it is clear to everyone. Moving on to a question, the next one, which was asked in JEE Main 2021. So what this question was saying, that a swimmer wants to cross a river from point A to point B. This is point A, this is point B. So line AB makes an angle of 30 degree with the flow of river, as we can see it in the diagram. This line AB is making angle 30 degree. So magnitude of the swimmer, magnitude of velocity of swimmer is same as that of the river. Fine. So the angle theta with the line AB should be what? So that the swimmer reaches point B. So in fact, this is not, neither the case of shortest time nor the case of shortest path. But you know what? It is easier than both of them. How? See, we want the person to cross the river along this line, right? That means the resultant velocity of man should be along this line. Then only the person will be crossing along this line. Okay. Velocity of river flow is in this direction. Velocity of man is in this direction. And given that both of them are same, that means let me call it as V and V. So if there are two vectors, so the resultant of those two vectors will be lying exactly between them. So this is vector V, this is vector V, and this should be the resultant. So this should be lying exactly between these two. And if the resultant is at an angle of 30 degree from one vector, so this theta also needs to be 30 degree. Then only it can have the resultant exactly between both the vectors, given that they have the same velocity, man and the river flow. So yeah, this is V, this is V, this should be the bisector of the angle, this is 30 degrees, so this needs to be 30 degree as well. That's what the answer to this question. So the angle theta with the line AB should be 30 degree. That's it. That was the question asked in JEE Main. I think it's very easy, right? Fine. Moving on to the next question, which was asked in JEE Main 2021 again. So a swimmer can swim with velocity 12 km per hour in still water. Water flowing in a river has velocity 6 km per hour. The direction with respect to the direction of flow of river water he should swim in order to reach the point on the other bank just opposite to his starting point. That means the question is asking about crossing the river in the shortest path. That means directly opposite to his starting point. So let's say this is the river. Let's mark the things. Swimmer can swim with velocity of 12 km per hour in still water. Okay. Velocity of river flow is 6. So let's say this is the velocity of river flow, 6 km per hour. And in which direction? Let's say if he wants to reach at the point directly opposite. So let's say he is swimming in this direction at an angle theta with the vertical, with this line. So he is giving his 12 km per hour in this direction. If he wants to go along the white line, that means perpendicular line. So definitely this theta should be in such a manner that this component, which will be 12 sine theta, should be cancelling out this 6, because 6 km per hour is the velocity which the man has because of river flow, right? So it has this 6 in this direction, 12 sine theta in this direction, and 12 cos theta in this direction. And if you want to cross the river in the shortest path, then I should only have this 12 cos theta. This 12 sine theta and 6 should be cancelled out. So 12 sine theta will be equal to 6. So I simply got that sine theta is 6 by 12, which is 1 by 2, which implies that theta is nothing but again 30 degree. Theta is again 30 degree. Okay, so I got this value 30 degree. What it is asking? The direction with respect to the direction of flow of river. I have to give the direction with respect to the flow of river. So this is the flow of river. Okay, if I will see the direction from this, so this will be the angle. So this is 90 degree and this is 30 degree. So my direction of flow of river water with respect to that, it will be 120 degree. That's what the answer to this question. And it is saying that round off to the nearest integer and find the angle in degrees. So yeah, that's what the answer in degrees, 120 degrees. So because from the river flow, it is making, this vertical is making 90 degree, and our answer is 30 degree from the vertical itself. So our answer is 90 plus 30, which is 120 degree from the direction of flow of river water. So that's what the answer to this question. So that's all from my side. And if you have any doubt, you can reach out to us in the comment section. Don't forget to watch the, the playlist of all the video lecture series. The link is in the description. If you still have any queries or suggestions, then you can reach out to us in the comment section. Thank you so much.